Hello, everyone. My name is Xavier, and I'm Associate Professor at the Department of Drug Design and Pharmacology at the University of Copenhagen. The interest of my group is to study and perform functional characterization of small RNA therapeutics. Our approach to this topic goes all the way from molecular mechanism, functional analysis, and preclinical models. Over the years, my group has worked on gene therapy application, biogenesis and decay of small RNAs, and the development of bioinformatic tools. More recently, we have focused our attention also to the mechanisms of pathogenesis, the use of preclinical models, and applications directly in the context of small RNA therapeutics. So if anyone has an interest in exploring further these areas on their ODIN projects, we will be happy to collaborate on that. In addition, our group has also posed an idea which basically focuses on the high throughput identification of on-target and off-target effects of small RNA therapeutics. The idea behind this project is the use of this method known as TRIPE that basically conjugates an RNA binding protein with an RNA editing enzyme, and using that in order to identify the targets of small RNA therapeutics. More in detail, what this approach looks for is to use this method to detect on and off target targets of small RNAs. We all know that Argonaute is the protein that basically brings small RNAs to a target of interest that some of those technologies try to regulate. Nevertheless, we know that Argonaute can also recognize other targets through the partial base pair complementarity. In order to detect which are the on-target and off-target efficiencies of these small nucleic acid approaches, we will develop TRIPE that will basically in turn edit the RNA and give a signal for those on-target effects. At the same time, this methodology will allow us to identify where off-targets are happening and be able to prioritize those sequences that have less off-targets and more on-target effects. In addition, we also envision that this tool could be used for the screen of pool siRNAs, and the approach here would be to screen in parallel multiple siRNAs and use the editing effects detected on the transcripts in order to prioritize those that have a more robust repression of the target, whether those that have less efficacy will give less signal. We also envision that this could evolve to the in vivo and primary cell applications, since that we will try to engineer a TRIPE construct that have a smaller size and could be also used in the context of lentiviral packaging or AAV packaging, as well as LNPs. Thank you so much for your attention.